Alright, here's the Lab 3 presentation for Kurt Edmondson's Power Electronics Lab 3 Pulse Width Modulator, Motor Speed Control. So here we breadboarded a DC motor control circuit, which we'll go into the details in a little bit later. First we're going to do a demonstration of the motor speed control. So if Mike will power on the power supply here to about 12 volts, the motor, as you can hear, it starts up at a slow speed. We have the speed controller set to a low resistance here, and as we increase that resistance, right, we can hear the motor speed up. And then as we decrease the resistance back down, you can hear it slow back down again.
Beautiful.
So there you go. There's a little demonstration of the motor speed control.
Breadboard and everything.
Right
All
on.
right.
So, and on our circuit here, here's the 556
The timer there?
timer. This is is that in focus there, Mike?
Yeah. 311
The 311
comparator.
which is connected here to the potentiometers for the speed controller, and then the transistor chip,
Which is our output stage.
the output stage.
Allows basically just taking up current. It's allowing more current to flow to the motor than our little 556s can provide. So here's a basic block diagram.
Right, so out of the 556, it has two stages here. The timer gives a pulse signal that you can see on the oscilloscope, and then at the output stage of that, the comparator will, and Mike, correct me here, jump in if I'm wrong, but
Sure.
this time here between the pulses stays the same, but it increases and decreases the width of that pulse.
So we're increasing our duty cycle,
Right.
essentially.
And then that in turn speeds up the motor.
That's right.
Based on the
Right.
comparator resistance.
Right. And there's our little well, it's not oversimplified, it's a beautiful thing, power transistor. So, let's see, I'll embellish just a little bit. So as Ryan said, one half of the 556, this is an A-stable multi-vibrator continually producing this. This is a one-shot or monostable multi-vibrator producing this depending on what's going on here and here. Essentially, in the schematic that you have in the report, you can see this speed and cutoff control is composed of basically a voltage divider. That control voltage goes into a pin on the one shot, and that is termed the control voltage, which, as we said, controls this. Should this voltage here fall below this reference point, which is, I believe, the negative pin on the 311, and I think that lies around 0.6 volts. If it falls below there, then essentially the reset pin on the 556 falls to 0, and that shuts output off. And that's based on the strobe pin on the 311. Power transistor, there's no way these can provide the amount of current this DC motor needs, i.e. power it needs to operate, so the power transistor's in place. The diode in the schematic is essentially for short circuit protection. And that is it. Your comments and feedback are greatly appreciated. We had a lot of fun in this lab, even though we couldn't hang out with you that much. But we learned a lot, and lab group, the op-amp group, plus Ryan Ness, thanks you.
Right on, and I'm not speaking for Mike Jones here, but I'm looking forward to summer term, because I don't think